So this is continuing video 2 of 3 from the mass hole diagrams, and we stopped at basically introducing that we are going to be talking about 4 main topics, which is reading the mass diagram, determining the load hole plan, determining the average hole distance, and determining the average grade. So let's go ahead and start by reading the mass diagram. We are going to be using an example, and in this example you can see from the table the normal cut and fill that we've used before when we were using the average end area method. This example is for common material that shrink from cut to fill. So the very first column is our station. The second column is the amount of cut in every single station and amount of fill in every single station. The third column is the equivalent bank cubic yard, which is determined by using the percentages string factor down here at the bottom to basically translate my embankment cubic yard to a bank cubic yard. And then finally you have your mass diagram, which is the BCY, which is what you use. This is the cumulative that we've used before in the average end area method, but here we're using this number, basically the mass diagram BCY, to plot our mass diagram. So let's take these numbers, and then if we plot them, there you go. You see the mass diagram starting from station 0, where we had on the previous slide, and ending at station 56. Let's again read through this mass diagram to understand what is exactly happening. Alright, the horizontal curve crossing means that the quantities of cut is exactly equal to the quantity of fill at that point. This is what we called the balance point before in the previous video, meaning that under this area, this exact area you see here, the amount of cut equals the amount of fill. So whatever I'm cutting, I can exactly fill in this location. Another point to see, so technically, before we move on, the balance points are going to happen from station 0 down here to station 27. And then another balance is going to happen from station 27 all the way down to station 46 down here. Another balance is going to happen from station 46 and ends at station 49. Look up there, you see the stations. So cut and fill is equal. Now what is really happening here? The curve is not hitting anymore the horizontal line. So that technically means that we are going to end up with excess amount of fill, right? So excess fill means borrow. And in this case, the excess amount of fill that we need is going to be 202,451 bank cubic yards. These few slides are more of an explanation of what I just went through, so I'm just going to go ahead and skip these slides, and you guys can go ahead and read through them on Blackboard. The second objective is to determine the load and haul plan. We sort of somehow hinted upon this before when I was talking about the balance points. But before we move on, it is important to remember that when we were talking about our pieces of equipment, different pieces of equipment have different functions and economical haul distance. So if we talked about our dozer per se, the dozer is economically used at a distance up to 300 feet. If you talk about push load scrapers or scrapers, then these could go all the way from 300 to 5,000 feet. Trucks obviously are the ones with the max greater haul distance of more than 5,000 feet moving the earthwork. So this we have to remember because as we're drawing our mass diagram, we are going to be cutting and filling, and we will need to use the appropriate type of equipment to do this operation. And this is exactly where we're heading right now with the load haul plan. The load haul plan, we're going to be using it to determine also where the balance lines will be. Based on what? Based on these pieces of equipment that you see up here. We are trying through our load and haul plan to cut and move the equipment to the shortest possible distance. We are trying to do that using the mass diagram, and as I mentioned before, haul is the movement of the material from a particular cut to a particular fill. We try to take the shortest cuts first, the shortest hauls first. If load and haul operations start from the shortest possible hauls and moves to the next longer haul and so on, none of the material will be moved more longer than necessary, and this would be the most economical load haul plan.
Alright, let's go ahead and read through this first. This is your mass diagram, and you can see how it goes from station A all the way to station K. some observations to make. The main one would be that it is balanced, meaning that the amount of cut and the amount of fill are equal. That is why when we look into station K at the very end here, it actually ends up at 0, where the primary baseline is, the primary, balance line is. All right, let's go along and read it a little bit. What is happening from station A all the way to station D? We are actually cutting, right? So we cut all the way from A to D, and then we start filling from D to E, again cutting from E to F, filling F to H, cutting H to I, filling I to K. Neat. Now, we have identified that these are the different quantities that are happening, and these quantities are really the quantities of excavation or earthwork, and it's determined, the QAB is really what the amount is from station A to station B. QBC is the amount from station B to station C and whatnot. These are determined also based on these auxiliary lines that we see. We see our primary balance line down here. That's basically the horizontal line. And then we see auxiliary balance line to auxiliary balance line. These auxiliary balance lines are going to help us determine also where the cuts and fills are going to go. We are now considering what their load haul plan is going to look like, and it's basically whatever is going to be cut is going to be filled with the same amount or the same quantity. So if you look at the bottom here, you see QAB is going to be filled in station JK, right? So AB is going to be cut, and then we're going to fill it in station JK. BC, cut, fill it in station GH. CD, cut, fill it in station DE. Station EF, cut, fill it in station FG. Station HI, cut, fill it in station IJ. These set of slides are just showing a description of what I just was talking about, so you can read them on Blackboard. Now, the idea we just were talking about is really what you call an option 1, no waste or borrow. Basically, that I'm not wasting any material, any excavation work, and I'm not actually borrowing any material from outside the site. So whatever I'm cutting, I'm actually filling. This case 1 is optimum if the distance between A and K is really small, it's not long. But if there's a long haul distance from A to K, a few miles, then it would be really, at this point in time, you need to ask the question whether it is worthwhile to actually cut at A and fill in K, or basically cut in A, waste, and then in K, figure out where we're going to borrow from. Technically, this is an economical decision to make, and it needs to be made based on the cost comparison of how much cost it would be for me to actually haul the material all the way from A to K, or actually dump the material and borrow additional material from another site. Now, if I decide to actually cut materials A to D and then stations A to D and then basically waste them, basically take them out of my site, not use them again, then at this point in time, what's going to happen is really this option 2 that we see. In option 2, QAD is actually going to be a waste. And then starting D, we're going to start with our new, basically, balance mass diagram, which starts at 0 at station D, and then it moves the same idea, but then the only difference is that when it hits the station K, we're going to end up with borrow material because we did not use the material that was from station A to D. In this case, what's going to happen is the same idea that we happened before, where we're going to be, in this case, cutting between L and E, and then basically using it for DL. On the same token, we're going to do the exact same thing for the rest of the mass diagram. The only difference is going to be that what we cut from station MN, we're going to actually be using to basically fill in here at the very end and station JK between. Basically, we divide it into borrow quantity 1 and borrow quantity 2. Borrow quantity 1 comes from station MN, and borrow quantity 2 is going to come technically from down here from station JK. This is a summary at the end, and it's not really for the same example, but it's showing you how the load haul plan would look like based on their mass diagram. If you have the mass diagram drawn at the very bottom, it's basically showing you, well, okay, this is going to be my first haul. My first haul is going to be moving from station BC, filling it in station CD. My second haul is going to be cutting in station DE, filling in EF. My third haul, haul number 3, is going to be cutting from station AB and then filling to station FG. And then my fourth haul, cutting again from IJ in this case, where you see the cut, and then filling in station HI. My fifth haul, cutting from station ML or LM and then filling into station KL. We are going to end up with some borrow material that we did not really have any fill from the site, so we'll need to borrow from an adjacent site or from an adjacent location. This is very neat because it's going to show you the entire load to hold plan for the entire site.